Today I'm going to talk about the chemistry of volcanoes and magma. What is magma? Magma is molten rock from the Earth's mantle that's mainly comprised of iron, magnesium, calcium, sodium, potassium, and silica. Silica content is very important to magma. There are two main descriptions of magma. We have our mafic magmas and our felsic magmas. Our mafic magmas are going to have a lower silica content, so they're going to be less viscous and they're just going to contain more iron and magnesium. Our felsic magmas are going to have a higher silica content, so they're going to be more viscous. Then we have three main types of magma. We have basaltic magma, which is low in silica, low viscosity, low gas content. We have our rhyolitic magmas, which are going to be high in silica, high viscosity, high gas content. And then we're going to have our anacidic magmas, which is just in between those two. The viscosity of magma is determined by its silica. So silica likes to form these crystalline structures. And so the more silica, the more, the longer of these crystalline chains, so the tighter and sort of less or more viscous the magma is going to be. The more silica, also the more gases that are going to be trapped inside because of this liquid state. Gases and contaminants are going to enter the magma but get trapped inside of these crystalline silica forms and not be released, which is going to increase the gas content. And the higher gas content, the more explosive the magma, or the more explosive potential that the volcano has if its magma has a higher gas content. So volcanoes with more felsic magma are going to be more explosive because of the higher gas content. Imagine like shaking a soda and then opening it. Once that opening is created, all the pressure that you built up inside is going to release. Volcanoes are the same way. The more felsic the magma and the more gases that are trapped inside, the more explosive potential it has because of the higher pressure. How does magma rise to the surface? So when two plates meet, one plate is going to, the less dense plate is going to subside under the more dense plate. The less dense plate is going to melt. The high temperatures and pressures of the mantle is going to push this new liquid rock, this magma, up, and sometimes it never breaches the crust and it just re-solidifies, but sometimes it does breach the crust and makes its way up to the surface as a volcano and then lava. Oceanic crusts are usually more mafic, so you'll find more of your mafic magmas and your mafic rocks around oceanic crust, and then your continental crust is going to be more felsic, so you'll find more of your felsic rocks on continental crust. And once this volcano does erupt, it obviously is going to have huge impacts on the environment. Two of the main reasons are because most of the gas found in magma is actually carbon dioxide and water vapor, which are two heavy greenhouse gases. So when these volcanoes erupt, obviously that's going to have an impact on the environment. But also the physical ash particles that get released can stay suspended in the atmosphere and in turn cool the planet. One example is the Tempora eruption in 1815, which was linked to drops in temperatures and crop failures all around the world. That's the now Tempora volcano. That's what it looks like now. And that is volcanoes.